In a nod to extraterrestrial mountaineers of the future, scientists working on NASA's Cassini mission have identified the tallest peak on Saturn's largest moon, Titan, which is about 3,337 meters high. That's roughly half the height of Mount Everest, which measures 8,848 meters. The highest point on Titan is found within a trio of mountainous ridges called the Mithra Montes. Most of Titan's tallest mountains appear to be close to the equator, researchers said. They found that all of Titan's highest peaks are about 3,000 meters in elevation. The study used images and other data from Cassini's radar instrument, which can peer through the obscuring smog of Titan's atmosphere to show the surface in detail. It is not only the highest point we have found so far on Titan, but we think it is the highest point we are likely to find, said Stephen Wall, deputy lead of the Cassini radar team at NASA's Jet Propulsion Laboratory in California. Researchers identified other peaks of similar height within the Mithra Montes, as well as in the rugged region known as Xanadu, and in collections of more isolated peaks called ridge belts. The investigation was originally motivated by a search for active zones within Titan's crust, places where dynamic forces have shaped the landscape, perhaps in the relatively recent past. As explorers, we are motivated to find the highest or deepest places, partly because it is exciting. But Titan's extremes also tell us important things about forces affecting its evolution, said Yanni Radebaugh, the Cassini radar team's associate at Brigham Young University in the U.S. Mountains and cliffs on Earth usually are found in locations where forces have shoved the surface upward from underneath. Forces of erosion, including wind, rain and runoff, slowly wear them down over time, researchers said. The Himalaya and Andes Mountains are examples of places where interior forces are at work today. The Appalachian Mountains represent much more ancient activity that produced similarly gigantic peaks long ago, which have since eroded, they said. Cassini has found that Titan also has rain and rivers that erode its landscape. According to Radebaugh, the process probably proceeds much more slowly on Titan than on Earth because, at 10 times Earth's distance from the Sun, there is less energy to power erosive processes in the Moon's atmosphere. The fact that Titan has significant mountains at all suggests that some active tectonic forces could be affecting the surface, for example, related to Titan's rotation, tidal forces from Saturn or cooling of the crust, researchers said. There is a lot of value in examining the topography of Titan in a broad, global sense, since it tells us about forces acting on the surface from below as well as above, said Radebaugh.